And yeah, should I go back or for the recording? Is that necessary?
I think if you can, if you don't mind.
Yeah, no
Sorry
worries
about
at all.
that.
Yeah, no worries. Yeah, okay. So let's start here. Today we're going to talk about automating and observing infrastructure deployments. You can find me on Twitter or you can reach out to me on LinkedIn if you have any questions after the presentations. So let's start. For this presentation, I'm going to make a few assumptions before we dive into the topic, because I think there are better resources out there where you can learn the fundamental things much better. The first assumption is that you know how to write and execute code. That's pretty self-explanatory. The second is that you are familiar with the CI/CD processes, and by that I mean that you already know how CI/CD works, and when we talk about the concept in general, you have an image in your head. The third is that you are familiar with the cloud computing. I assume that most of you have some hands-on experience with some cloud provider, but that would be a good assumption that if you know what we're going to talk about, it will stick with you. We have a pretty straightforward outline for this presentation. So we will talk about infrastructure as code in general, what it solves in our day-to-day life, what the ecosystem offers, etc. And I will talk about the automation, and then I will give some examples from Tundra on how IAC tools and automation transformed our infrastructure. Then, depending on our time, we'll take a quick break, and I will show you some code examples and how CI monitoring works on Tundra. So when we say infrastructure automation, we mean the things that we implement to reduce the human assistance of any task that touches to your infrastructure. So on your cloud infrastructure or your on-prem servers, there will be tasks that will be handled by the machines, scripts, and applications. Those are what we are going to talk about. Manual provisioning and the management is painfully slow and prone to human error, as we'll be talking about the upcoming slides. So to improve this software development lifecycle, as we call it, delegating the tasks to the machines that runs the scripts or the applications that you implemented will be crucial, and it will be in the long run will benefit more than the effort it takes. So before the infrastructure as code, before IAC tools emerged, so there were some, let's say, some main problems that were causing issues in our daily life. So toil, and we mean by toil is that the manual work that you are doing is probably the biggest setback to your productivity. So doing things manually, all the administrative tasks, is basically it's an edge of an endless pit of technical debt, and you are definitely fall into that trap. As a side effect of these manual operations, we'll have new problems. So configuration drift between environments is one of them. So as you go along to your daily life, there will be inconsistencies between environments. It will definitely happen. Sometimes you make some changes on your lab environment and you forget to do the same on the production, etc. And the knowledge of that, what configuration goes where and where to look when a network problem occurs, stays within a very small number of people in your organization. So worst case scenario, only one person know what's going on, which is just awful. So and we know that humans are not perfect, obviously. So we can forget things, we get sick, we need rest. So when those things happen and only few people knows what's going on, things will break, and things shouldn't break just because we simply couldn't manage to share that insight with our teammates. As a result of all these items, we can't automate stuff. So these problems are the biggest stone on our road to automate stuff. With IAC or automation tools, we are solving these problems, almost all of them. So we have almost no toil with IAC. So there will be obviously things that are hard or impossible to automate, or just simply don't worth the effort, doesn't worth the effort. However, we should try at the very least. With IAC, we now have consistency across environments if we don't mutate things manually. And this is a big if, and it comes with the responsibility. So if you're doing things with IAC tools or automation, you shouldn't touch it manually. We can share the code base, and anyone in our team or engineers after we are gone from that company can work on this project without any issue and can make changes without causing any problems. And with all of this, we have almost no human error. We can say that, but it's still possible for us to make mistakes. However, this time we have a framework and the reference to work on. So if we make mistakes, there will be warnings, there will be problems that we can always roll back. And as a result, things are now automatable. In the market, there are different tools that fall into the IAC category. So in no particular order, there are some like CloudFormation, Terraform, CDK, and maybe senior people will know that there are Ansible, Puppet, etc. And these tools, maybe we can separate them into two categories. One will be the declarative ones, and one will be the SDKs where it's programmable. So CloudFormation and Terraform are declarative IAC tools. You write YAML or configuration files that you define the final state that you desire. And with CDK and Pulumi, it's a little bit different, where you are writing an application that's running to complete the tasks. And these are called SDKs. You can call them SDKs, and you can do all sorts of things that you are doing with any programming languages. So before we made the transition to AWS CDK or IAC in general, at Tundra, we were in a substandard situation where parts of our infrastructure were done manually, and so this was a problem at Tundra because it caused us. We were not agile. We were not mobile. We couldn't move. We couldn't change anything, and some parts of our infrastructure were written in AWS CloudFormation. But even the parts that's written in the CloudFormation, it was hard to onboard people to understand the resources at play on our production environment. In some cases, CloudFormation templates were just there to bookkeep. So we were changing the AWS manually, but writing the YAML file and committing to the repository to bookkeep the changes, which was not standard at all. And the YAML files and the JSON configuration file were everywhere. There were no configuration there were some configuration that no one wanted to touch. No one knew how it works. No one knew where it is. And as a result, we couldn't automate stuff. We can't create new environments easily, etc. With this infrastructure transformation at Tundra, we still have some manual configurations, such as setting up a VPN, creating AWS users, etc. But now anything that is automatable are automated, and everything is written in AWS CDK. IAC codes are very well organized throughout the company. Since we have now a final state for everything, we can test stuff on AWS without a fear. So we can battle test the network configuration, because if we make any mistakes, we can always roll back to the state that we have. And we have better management for the whole company. We can spin off a new product environment with a few commands, and within like half an hour, we have a new environment that's ready to push to live for a new product. I hope this is visible enough for you, but as an example of what our infrastructure looks like nowadays, this is a bird's eye view of our one of our product sidekicks networking diagram. So all of these resources you are seeing here are, and their configuration are written in AWS CDK. So on the left-hand side, if you split the screen on the in the middle, on the left-hand side, you are seeing two VPCs. One is the VPN VPC, one is the SRE VPC. And these are pretty standard. So these are always there. And if we create a new environment, these will be created as a standard. On the right-hand side, the resources on the right-hand side will change depending on the product's needs. So we can create databases if that's the need. We can create Elasticache resources or Amazon MQ resources, etc. So and this complication is hidden, and it's in a repository where you can apply them with just few comments. And on the very left side, you are seeing a developer reaching out the Slack bot. So we've implemented a Slack bot to manage our deployments. So all this complication, as I said, is hidden, and all our engineers have to do is to interact with that Slack bot. So basically, we've written our own CI/CD tool, and with that Slack bot and this repository that's keeping the state of this architecture, anyone in our team, any developer, whether that person is doing front-end development or back-end, can do any changes and can create new resources if they need to, without the assistance of a DevOps people. We have this culture at Tundra that anyone can touch the infrastructure if they need to. And since it's very well organized and it's clear, anyone can do it by just reading the documentation for AWS CDK. And before I talked about what the market offers as an IAC tool, and the reason we choose AWS is that we use AWS as our main cloud provider, and we are an AWS technology partner. We are also working with AWS on the AWS Lambda partnership side. So we are very close with the AWS people, and we know what's out there, and we have an understanding of CloudFormation. So since AWS CDK synthesized into CloudFormation, we knew that if we encounter any issues, we can resolve them easily. And we preferred programming languages over markups, so we didn't want to write YAML. So, and CDK is easier than writing and managing YAML and JSON. And I want to emphasize writing here, because when you write YAML and JSON, you literally write them, you don't implement anything, and it's not exciting, it's exhausting at the very least. I've seen a question on the chat. Let me talk about that a little bit. So question is how much it's important to use one or more IACs and CDKs, which is a good approach, using one infra as a code service or multiple. So that's really depends on your architecture. So AWS CDK obviously only works on AWS. So if you have some resources that's on Google Cloud or Microsoft Azure, you are going to you will want to use some how do you say that, platform agnostic IAC tools. So such as Pulumi is one of them. Pulumi can create resources on Google Cloud or Microsoft Azure or AWS. Same as Terraform, which is a declarative part, and so you can use both of them together. It's really up to you, as long as you manage the resources correctly and you don't cause any override or issues. That's perfectly fine. I hope that answers your question. So let's wrap up the general talk about the IAC. So problem itself, when we talk about the problems, we say that with IAC and AWS CDK especially, you don't need to be a YAML engineer. No YAML fatigue or JSON fatigue. You don't exhaust yourself, and it's programmable, and you can do, for example, we do some async creation with the AWS CDK, where we check the resources while they are creating. So that's definitely possible, and it's really enjoyable to write in a programmable language. So it's almost fully autonomous. So as I said, there will be resources. There will be resources where you need to do manually or doesn't worth the effort, but it's autonomous. We can say that it's fully autonomous. And anyone can implement or provision new resources without any issue, and anyone can find what the implementation is where. You can test the network configuration. You have the final state that you want to work on. There's a new question on the chat. Mohammed asks, how would you test code in AWS CDK? So testing in AWS CDK is one of the things that we want to explore as Tundra, and as personally I want to explore that, but there isn't much to do in the AWS CDK testing part, unless you are testing the desired state of that stack. So as far as I know, you test the outcome of that stack where there's a resources. Let's say you created AWS Lambda in your AWS CDK, and in the test part you say that, when this synthesized, I want to see that AWS Lambda configuration in that CloudFormation file. So that's as much as I know for the AWS CDK testing part. But there are people out there basically documenting how you're going to test that, and the CDK book, I believe it's a good example, a good reference for the AWS CDK testing. If there's any other question, I can definitely take them. And I hope that answers your question. So when we are talking about automation, and so basically automation means that you are going to use machines to do your job, and you should use the machines, and they are definitely there to serve us. I want to ask the audience that has anyone played or heard about the game Factorio? If you haven't heard about that, it's a construction and management simulation game where, as part of the game, you would automate and improve the efficiency of your production pipeline. So it's a heaven for an automation geek like me, and I'm pretty sure people like me will definitely enjoy it. When I think about the automation and the CI/CD processes and the things going on the production with your software development lifecycle, even in software engineer, I think about Factorio. But the advantage of a game is that you have a bird's eye view of your factory, and if there is any issues with any of your components, it shows a warning message that you can't miss, and you would have to interact with that and solve the issues before you continue playing the game. This brings us to the our observability habits. So in our life cycle, we have some basic components which we can represent in such a way that this is the DevOps software development lifecycle. We can split them into two parts, and the left side and the right side. So and these categories, and if you can split into different categories, ideally the only human touch in your system, in this system, should be in the development phase. We currently have APMs, application monitoring tools, that helps us to observe our code on production. So when our code goes to production, the APM tools that we integrate with our code will monitor how our product are behaving. But as we follow the line to the backside on the left, our visibility of the processes dramatically decreases. Most of the time, the CI/CD machines that we are working on works behind some kind of an abstraction, where you don't get much information of the processes unless you implement the hacky way of getting it. So the trend of observing and monitoring the pre-production line of your pipeline is called shift left observability. I personally draw the line before our code goes to live. Ideally, we want more than the images we see from the factory. We don't just want yellow icons that says there is something wrong here. We want to see failures and their root causes easily. We want to get test performances. We want to get resource metrics. Cost and time visibility is definitely will improve our will solidify our journey in the software development side. And we basically want to monitor everything. So in this ecosystem, let me talk a little bit about Tundra, because we started as a application monitoring tool. From the previous images, that's where the code lives. So that's when we go to production. So we learn a lot of things from the APM side. We did a lot of exciting stuff with the APM features. So such as we have some, we support 5 different runtimes. We did some serverless and non-serverless application monitoring. We did some distributed tracing and what we call is a time travel debugging. So as an example, what an APM looks like, if you haven't looked in any of the tools, here's what it looks like. So on the left-hand side, you are seeing a bird's eye view of your architecture, as with you see in a game. And on the right-hand side, you are seeing the time spent on the resources in that architecture. And there will be there is a snapshot, as we call the time travel debugging, where we record the invocation for this architecture view, and you can basically play this anytime you want, line by line. So this is what we call the time travel debugging. So all this application monitoring know-how all the problems we solved here moved us to the Thundra Foresight. So Thundra Foresight is our CI/CD monitoring tool. At the time, we were having problem to monitor our test performances, where there were nothing on the market that was solving this. So that pushed us from the edge that we want to implement this. We want to solve this problem. So in this ecosystem, Thundra falls from the production line to the left-hand side, and we want to cover everything. So we want to cover your production environment. We want to, let's say, we want to observe production line as much as we observe the once that code goes to live. So these are the pain points that originated Thundra Foresight. And with this shift left observability trend, we want to have a place in this ecosystem, basically. So I believe we can take a little bit break, like a 5-minute breaks, and then I will show you some AWS CDK examples, as well as how it works on Thundra Foresight, how you monitor your CI pipeline, and how it looks on that. So Ali, is that okay if we can take a 5-minute break?
Yeah, I think that should be okay.
Yeah. Okay. So let's get back together in 5 minutes. In the meantime, if you have any questions, I believe people from Tundra is in the chat, and they are happy to answer your questions, as well as I will answer questions if I can.
Yeah, I think it's better if everyone like has any questions, like you guys can ask anything.
Yep, this is a good time to answer your questions.
Yeah.
Yes.
Hi.
Hi. Hello.
Yeah. So I have a question. So
Yes.
in AWS itself, they are providing some inbuilt services like X-ray to
Yes.
monitor and debug serverless application.
Yes.
So in contrast to that, why did you guys like build a separate service? What were you trying to solve that is not solving by the AWS X-ray?
Yeah,
Thanks.
that's really a good question. So for the application monitoring side, with X-ray, you didn't get the bird's eye view. Some services were not visible, I believe, such as SNS or Kinesis. But X-ray is constantly improving. But the thing that originated the application monitoring is to propagate all the resources and show a bird's eye view for every resources that's at the play. And from AWS Kinesis to SQS, from your DynamoDB queries to let's say AWS Lambda invocations. So everything is to view everything in one single screen was definitely the motivation for us. And for the CI/CD monitoring, I don't know if AWS doing anything, but for serverless debugging part, at the time, and still I believe the big differentiator for us that we are debugging things on the production, and there's no mocking or anything. So I hope that answers your question.
Yeah, thanks.
Okay, thank you.
Yeah, a small reminder, guys, if you guys can just like register for the quiz, I think it would be great. So you guys can also win that $50 gift card.
Okay, so I believe we can come back to the presentation. I don't see any new questions, but if you have anything in the meantime, you can definitely post it, and I will try to answer that. So let's see some examples, and let's start with a simple serverless stack where we create a AWS Lambda. So in this snippet, you are seeing some imports where we import the AWS CDK library, and we are creating a CDK app, and we are naming our resources as Lambda stack. In that Lambda stack, which is a different file in a different class, we are defining some resources that we want to create. So as an example, if we want to create an SQS queue, well, personally, I write in TypeScript and I want to define the types. So I define the types and I say I want to create a new SQS queue with the queue name is this. So that's basically the CloudFormation counterpart of in the AWS CDK. So as I go down, I want to create a new Lambda function that's triggered from that SQS queue I created before. So as you see here, you can set the event type as an SQS event source, and you can create you can define your function handler as you would do any kind of a like serverless framework, for example. And you are doing all this in a TypeScript application, in a Node.js application, and it's pretty easy to define things, and you can do all the calculation, etc. And in the in this let's say in this entry file that in the lib as source s3 upload ts file where I defined the Lambda function, I write a simple handler function where I export it as the handler. So all of this is enough to create a Lambda function that's triggered from the SQS where I created it in the same stack. So when I apply this AWS CDK, it will create a new stack on the AWS CloudFormation page where it will create new resources all together and as it's seen from the here, it's not complicated as it is on writing like a JSON file or a YAML file. So it's your habit of writing programs doesn't change when you create something on the infrastructure. And to automate this, this is a very basic GitHub action workflow. To automate this deployment, I just set up the Node.js and install the AWS CDK. And in this deploy sh file, where I trigger to do the deployment, it's just doing the npm install and the creating the resources on the AWS and deploying the stack altogether. So all these 3 lines of code, even we shouldn't count the npm install part. So let's say CDK bootstrap and the CDK deploy is all you need to create the new resources. And if you remember the network architecture of our product Sidekick, as I showed, all this complication can be automated with just 2 lines of code. And when we see it on the AWS CI, when we see it on the GitHub action, we see that, well, I had a change set workflow and the deploy job to create these resources. And I can see that it spends like 6 minutes here, and on AWS, I see that my resources are created easily. But when I want to monitor this machine and the CI/CD machine, and I also want to see the previous runs when there is a failure. I go to Thundra Foresight. So if I can show you some live examples in the screen, I believe it's visible. You are seeing my workshop workflow that's showing the latest workflows. And if I go there, sorry, let's wait for it to refresh. I can see that when there is a failure, I see that it failed on the change set step. And for the highlight to, let's check this again. Sorry about that. And when I connect my CI/CD machine to Thundra Foresight, I see the previous runs for my CI runs. So I see when there's a failure as a historical data, and I see the most active workflows. If the cost is an issue for me, I see the cost estimation. So which runs is taking the longest is a good way to optimize the stuff. And what we did at Tundra, as we have this product, Thundra Foresight and the Tundra APM, we are monitoring everything with our own products. So if I show you here, this is our whole production pipeline for Thundra Sidekick. And we see that everything is currently green. All the CI processes passed here. And if I go to highlights here, let's see. There will always be issues with the while doing a demo. So let's go check the last 7 days. I can see my our CI performance here. So this is something we wanted to do at the time, and we are achieving this. So we are observing every part of our production line with our own product, and I can check the which one of my workflow is the most failed ones, which one of them is taking the longest. So here I can see that our backend build for Java is taking a lot of time. So if we want to optimize that, we are seeing it here. And we want to improve this, and we want to make this as part of your daily life. And this is something we wanted to, we are very excited. And sorry, I've seen this question now. What is the difference between the Grafana and Tundra? So let me answer that quickly. Grafana is just a visualization platform. So you push the data and it visualizes for you. Where in Tundra, it's an SDK that you plug Tundra into your code, and we do the monitoring for you. And for Foresight, you select the repositories that you wanted to watch, and we collect the data from our application. I hope that answered our questions. Is there a way that we can share this dashboard outside? So we are currently, these dashboards are private to your organization. So you can invite people into your organization and they can see it. And there are roles for people in your organization. So kind of like a read-only user and someone who can make changes. But making this public is definitely on our roadmap. So you can share this roadmap, share this dashboard. If you have a, for example, if you have an open source project and you want to share that to everyone, that's definitely possible. And we want to hear the feedback and the let's say the desire from the users that if they want to if you want to make changes, that's going to worth it. Okay, so let's go back to the presentation, and I believe this is as a further reading, I want to share these links, and I don't know if there's a way to upload this presentation somewhere, but I will definitely post it on my LinkedIn and on Twitter. So as a further reading, the documentation on Tundra is thorough, so you can go there, go there and try it out for yourself. And this AWS CDK example that I showed is public, so you can go this Thundra-io-demo organization and see the workshop for yourself. You can deploy it to your own AWS account, which will create an AWS Lambda that's triggered from the SQS and will upload the results to S3. The AWS CDK documentation is pretty basically the best reference out there, so you can go out there if you want to make any changes to the demo. You can do that and try it out. And I wanted to show my personal blog where I sometimes post CDK tutorials to basically show people that CDK is worth a try. So I believe that's it. Thanks for listening and thanks for inviting us. If you have any other questions, I believe we have still 10 minutes, so I'm happy to answer your questions.
Yeah, thank you, Oz. It was a very informative session. And I think we can start the Q&A session now. If you guys have any questions, you can ask now, or else you can drop your questions in the chat. Yeah, on that, I have one small question, Oz. So, like, is there any cost pre-built for this integration when it comes to Tundra?
Or like, no.
Oh, yeah.
Yeah, that's sorry. Continue with your questions.
Yeah, so like I mean, like not an overall costing way, but maybe like something like we should pay for, or like is it like there's like nothing that needs to be paid for?
There's nothing to pay for at the moment. So Tundra APM and Thundra Foresight is free to try and free to work on. So so we have a free plan, and for APM there are paid plans, and for Foresight, since we are one of the few tools on the market, we are still figuring out what the people need and what the problems out there. So we are trying to solve the issues, and we are hearing people. So the pricing is currently none. So it's free to try it out. Yeah. So that's the answer.
Yeah. Thanks on that, guys. What about others? Like, is there anything? I think there is one in the chat.
There is one in the chat. So is there any section which shows the impact to your system? I don't know what you mean by the impact to your system. If you can clarify that, I can happy to answer that. I'm happy to answer that.
Yeah, I think if you can just unmute or maybe just drop that, it would be easier.
There's another question from me. I'm Manoj, by the way. Yeah. So let's say that there's a project who has been using serverless framework because it was introduced quite a long time before the CDK and the Pulumi and those things come to picture.
Yes.
And we have been like using these abstractions like serverless, keep creating the APIs and Lambda through the serverless framework. And if we wanted to create other resources, we use CloudFormation just in the serverless itself. So what are your thoughts about, let's say, creating these other resources except for this Lambda and API gateway, which itself the platform or the serverless framework supports? Should we use, let's say, CDK for creating those resources, or do you think using two type of IACs is sort of a bad thing in the project?
Yeah. So I can definitely give an example from our own production line. So we use serverless framework as well for our AWS Lambdas. So sometimes we create it on AWS CDK because if you remember from the architecture from the Tundra, there are two parts. So there are the SRE part that's doing the core infrastructure, and there is the product side. And on the SRE part, we are using only CDK. So if I need some AWS Lambdas to do some mundane network configuration type of stuff, I create it on the AWS CDK, where it would be better if it's in one piece. But on our product side, if our backend needs some AWS Lambda, or if that AWS Lambda needs some SNS, let's say, we usually either create a very one stack that's common for all these resources where we nest stuff. So for SNS topics, we have one stack that's creating before the Lambda goes, or if that resources isn't that complicated, isn't that to configure, we create it in the serverless YAML itself. So it's really how you play it. It's really depending on how is your organization works. So so there is really no one single answer for that. So if it's good for you, if you are productive with the serverless side and writing the CloudFormation there, that's perfectly fine, I believe.
Yeah. Another follow-up question there. How did you share the resources built from CDK, referencing the resources that is built in serverless framework? How did you guys do that?
Yeah, great question. So in the past we were doing CloudFormation output. So we would output the, let's say, Amazon resource names for let's say one queue or something else, or the URL for the databases. But we now using AWS Secret Manager and the AWS Parameter Store to create some, let's say if we are creating a MySQL database and we want to share the secrets with the Lambda that's calling that database, we are using the Secret Manager to output that information and import that in the serverless YAML itself. So that's really how we work, and we made the change from CloudFormation output to parameter store and Secret Manager to basically get more secure about it.
Okay.
So, yeah.
Thanks, Oguzhan. I think I
thank you.
spelled your name correctly. Thanks.
Yeah, it's perfectly fine. I believe there is one question.
One more question.
Yeah. Do we have a way to see the Tundra code base to see how things are done? So Tundra code base is private, but there are some public repositories where we use GitHub Action to automate stuff. So our agents are public. So Tundra APM's agents are public, and those are working. Those are released through a GitHub Action. So our CI workflows are public, basically. So if that's something you want to tinker in, you can definitely go there. And I'm not sure, but we have a environment. I want to show if that's still alive. we made some changes. The highlights part that I showed here didn't came to the live environment, but there's a foresight.tundra.live environment, which is public and it's read-only. You can see how the example repositories works, how the test performance is out there. So I didn't get to talk much about the test performance, but there is a test run monitoring here as well. So you can see the all the test suites and the all the slowest tests, etc. here as well. So there is that part too, but it didn't fall into this presentation, but there's out there. What source of authentication required for Tundra? To create a user, you can you can create you can sign up with Google Authentication or GitHub as well. So it's pretty basic for a SaaS product. And let me just show you our let me open this here. Thundra.io is our organization is here, and there are some public repositories that as you can check. So if you have a GitHub account, you can sign up for Tundra with GitHub or Google as well.
So hi, what was my question is like, since it's what sort of AWS access permissions we need to give to Tundra to get the collector? That's the question.
I see. Okay, so for APM, you don't need to give any permission. There are some parts that you can, if you want, let's say, let me just say it this way. There are two types of monitoring for your Lambdas or your applications on AWS. So one is with the CloudWatch monitoring, which then Tundra needs to read your CloudWatch logs, and there is a CloudFormation template from Tundra to give that access, but it's not needed to integrate Tundra. All you need to do, add the layer to your AWS Lambda. For Thundra Foresight, you have to give access to your GitHub organization or your personal GitHub profile. And even then, you can select the repositories to watch. So you can only give access to one repositories. And all that Tundra does is to read your GitHub action invocations. So for APM side, there's really no need to give any AWS permission. You can plug and play Tundra with your code. Yeah, I hope that answers your questions.
Yeah, sure. Because I had a concern because what sort of things will be accessed from the Tundra. So
that's understandable. Yeah.
Thanks.
Yeah, I think if we don't have any more questions, we can jump to the quiz then. Yeah, seems like we're also running out of time. So
yeah,
since we don't have questions, I will just share my screen.
Let me give it to you. Okay.
Yeah. Thanks. Okay. Okay. Give me a minute.
While Shoaib is getting ready, Oz, there's another question in the chat. If you can maybe take that.
Okay. Is Tundra automatically starts on changes to the Git branch of the code commit repository? So Thundra Foresight, let me clear this way. So Foresight isn't specific to AWS. I believe code commit is AWS service. Is that right? We track some very basic events from GitHub. So one is the workflow started, in progress, and done. That's the and the parts between that. So the only actions we are tracking is your GitHub action workflow runs. So if it's not triggered in a way, Tundra isn't going to trigger that for you. But if you have a workflow that's triggered when there's a merge on the master branch or the main branch, Tundra will get that information and shows that workflow run on Foresight.
Yeah. I think the quiz is shared by Keshav.
Yeah, I can see this screen. Yes.
Hi, Shahid. Hi.
Hello. Yeah.
Hello.
Yeah. We will be starting the quiz in a while, so you guys can go to that link in the chat and register for the quiz. So we'll be starting quiz in within the 2 minutes. If anyone needs more time, you can drop a message, or else we can directly start the quiz. Okay, I think everyone have registered, so let's start the quiz then. Which one of the following is not an IAC tool? First answer is CloudFormation, Aws Cdk, Docker, or Colombo. Chance is yes. If you have properly listened to the session, you can answer these questions easily. Okay, many people have answered correctly. Let's move on to the next question. Which game did the presentation mention as an example of automation management? Is it Minecraft, FIFA, Grand Theft Auto, or Factorio? It's an easy question. Okay, let's see. Going to the next. Which of the following is a Thundra's CI/CD observability solution? Is it Thundra Sidekick, Foresight, Thundra APM, or none of the above? Yes, it's Thundra Foresight. So this is the last question, guys. Be hurry when answering. Last question is, which one of the following is an advantage of IACs? Yes, we have a winner who is Don Adhikari. Congratulations, Don Adhikari, for winning $50 worth AWS credit. So if you can please drop your email in the chat, we can contact you after the session. So that's the end of the quiz. Over to you, Shah.
Yeah. So congratulations, Ron. So apart from that, I think like whoever didn't get the credit, just don't be disappointed. There is always a next time. So you guys can join for our next session. Yeah. Apart from that, I would like to take some time and thank Oz for accepting our invitation and taking a bit of his valuable time and sharing the knowledge with all of us. So
thank you. Thanks for inviting us.
Yeah, so great job, and hoping to see you all in the upcoming sessions.
So thank you everyone for listening. I hope that the presentations open some things in your mind and you have some insight about the infrastructure automation.
Thank you very much, Oguzhan. Very informative.
Thank you.
Thanks.
Thank you all.
Yeah,
Thank you guys.
all.
Thank you. Thank you all.
Thank you.